Okay, so in this video I will be showing you two methods to solve chemical equations or to balance them. There is the easy normal way that you can use for small reactions like the one right here, and then there's the algebraic way that I just discovered and looks really helpful. I found it on WikiHow. I really struggle with balancing chemical equations in AP chemistry, so I hope I can teach you and make sure that doesn't happen to you. So the first thing you're going to do is write down your equation. I already have that in front of me. And the next thing you're going to do is write down the amount of each thing that you have. And by the way, if you don't know what balancing is, in case you just skipped middle school, basically all you're doing is making sure that all of your atoms match so that your reaction is possible. For example, in this equation, you have 3 carbons on the reactant side and 1 on the product side. Therefore, this reaction would never ever happen in any situation because where are these carbons going to go? I don't know. So we're going to make this work. We're going to add more of something to make this actually possible and feasible. So I'm going to write down each of what I have. So 2 hydrogens, 1 oxygen. No, sorry, 3 oxygens, and then 1 carbon. Just making sure that's right. Okay. So now I'm going to save. So basically balancing, you're going to be multiplying each of these by a certain number. So for example, I could multiply this C3H8 by 2, and then I'll have 6 and 14 carbon and hydrogen respectively on the reactant side. But I'm going to focus first on carbon because carbon is only in one product on each side. I mean on one compound on each side, so that'll be a bit easier to balance. So immediately I can tell you that since there are 3 carbons on the reactant side, I'm not going to try to multiply anything on the reactant side for carbon. But on the product side, I have less carbons, so I'm going to multiply CO2 by 3 so that I can have 3 carbons. But consequently, I'm also going to have 6 extra oxygens, or I guess 3 extra oxygens. So then I'm going to have 1 plus 6, so I'm going to have 7 oxygens here. Alright, so now I'm going to want to work on my oxygens and hydrogens and try to balance those. So now I'm going to look at my water because I need more hydrogens. So I'm going to multiply my H2O by 4 so that I can get 8 hydrogens. So then H will become 8, and then I'll have 4 oxygens plus 6 oxygens on the CO2 side, which means I will now have 10 oxygens. So now I'm going to need to balance it so now that my carbons and hydrogens are looking good on both sides. I'm good here. I mean, no, not my oxygens. My hydrogen carbons are looking good. I'm going to need to balance my oxygens now. So you can see that I need 8 more oxygens to balance out my 10 oxygens on the product side. So all I'm going to do is I'm going to multiply my oxygens by 5 so that I can get 5 times 2, 10 oxygens. And that's a balanced chemical equation. I'm now going to get into a more complicated but easier to use. Not easier to use. It's easier to use in larger equations and more complicated equations. It's called Bottomley's method. I just looked it up. It actually is really cool. I'll write down the equation for that in just a second.
This is a certified hood classic.
Here we are in nature. People say I need to be more organic and natural, so I went to the woods. I don't believe in science. I don't believe in science. It's creepers.
Okay, so the first thing you're going to do for Bottomley's method is that you are going to assign a letter to each substance. So A, B, C, D. Alright, so now you are going to set these letters equal to each other as if they were variables, so according to which element they are. So we're going to look for each individual element here. So we know that we have P, phosphorus, chlorine, and hydrogen. The oxygen can come later. Those are the ones we're going to focus on for now. You can also do oxygen, but I'm not going to do that yet. So we know that there are equal amounts of phosphorus on both sides. So for every phosphorus on A, there is one phosphorus on C. All right. And then for Cl, or chlorine, we know that 5A, since there are 5 chlorines, is equal to 1D, as there is 1 Cl on D. All right? And then for hydrogen, and by the way, I'm using the equal sign, just means that, like, you're traversing on both sides. So on this side is products, on this side is reactants, and this side is products.
Life could be a dream, life could be a dream. Do, 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 shaboom. Life could be a dream. If I could take you up in paradise up above.
Anyway, next thing is hydrogen. So 2 B's. So 2 hydrogens here.
Jesus Christ, that's Jason.
Equals 3C, because there are 3 C's on hydrogen, and 1 hydrogen on HCl. So D. Now this looks really crazy, I know, but next thing you're going to do is that you're going to solve the system equations to get the numeric value for all of the coefficients. So we already know that A equals C, so we can plug in C for A, and we know that both of them equal 1. So then you're going to just say that A, so 5 times 1 equals D. So now we know that D equals 5. So we know that let me just make that more. And then we can plug in D for H. So then we know that. And we can also plug in C. Right? Yeah, we can plug in C. So then we could say B equals 3 times 1, because C we already established equals 1. So 3 times 1 plus 5 divided by 2, because, you know, algebra, will give you 4. So then B equals 4. So we need 4 hydrogens. And that's all. So let me just write this out in the balanced format. So A and C equals 1, as we solved before. And hydrogen is 4, so 4 hydrogens. And then 1 of the H3PO4s. And 5 HCl's. Now, I think that this method is really useful. It's a little bit confusing, but it's just algebra. So if you want to use it, you can. Yeah.
I love you.
That's the end of the video. Thanks.